All right, so Unit 9, it's going to be a unit where we focus on graphing, as I said a couple times, some special equations. Okay, we're actually going to be focusing on two types of equations for most of the chapter, which again requires some special techniques. I actually want to do something that, just sit back a little bit. Now, don't scroll through Twitter, but sit back and just preview this with me. You don't have to write this down. In fact, I don't want you to write it down. You'll miss what I'm trying to show you, which is simply a little preview of two of the equations we're going to do. Okay, now here's an equation that probably, unless you've spent time independently studying, you have not graphed before in any detail, and that's fine. It's a rational function. It's a fraction. So when you graph a fraction, you get all kinds of special things going on. Now, the main reason that you get special things going on is because the denominator, and I hope that you have some knowledge that the denominator can be a bad place when it's equal to 0. When a denominator is equal to 0, bad things happen in math. And when a denominator is equal to 0, strange things happen with a graph. Now, again, just kind of watch. I'm graphing this. I'm using a calculator. We could also use Desmos. But just look at it with me. We get an interesting graph. Okay, it's not a heartbeat. Might not be a good one if it was, but it's actually a graph that's got some bad places. Now, one bad place is connected to a number that if you plug it in here for x, you would get a 0 in the denominator. It would be the number -3. Just think about that with me. If you plug in -3, you can get 9 minus 9. -3 is a bad number, and it's showing up on this graph as what's called an asymptote. Now, we talked a little bit about asymptotes back with sine and cosine. But basically, an asymptote is a place on a graph where you can't get to, you can't touch. And you can see the graph is kind of doing that. It's like not touching. It's not technically touching its asymptote because it's going up, up and away to infinity. Or it's going down, down and away to negative infinity. So the graph is doing that behavior where it's not able to get to -3, but that's good because -3 is a bad number. Now, there's another bad number. If you square another number and -9, you get a 0 in the denominator. It's not -3, it's +3. +3. Now, why is +3 not showing up as an asymptote? Well, because it's actually a hole in the graph. I'm not making this up. There's a hole right there, not at the bottom of the C, but at negative or at +3. Now, what do I mean a hole in the graph? Well, if I was walking along this graph, minding my own business, when I get to 3, I literally would drop and vanish. Okay, let's walk along this graph a little bit. You're a spider. Okay, we're getting closer to 3. Okay, actually what I'm going to do is I'm just going to go straight to 3. I'm going to type in the number 3. And what happens? Poof, you're gone. Okay, now the reason you're gone is because there's no y value. There's no value. We literally fell in a hole at 3. Hey, we'll talk about like why there's a hole there and why there's an asymptote at the other -3. But there's another asymptote altogether. It's a horizontal asymptote. If I tilt this the right way, yeah, you can kind of see that the graph is doing the same thing. It's getting like closer and closer to that line. We usually show it as a dashed line. And that dashed line is actually at 4. And we'll talk about why 4 is another asymptote. By the way, 4 is not an x value, it's a y value. And it's not necessarily a bad number. It's just a number that the graph continues or is also unable to get to as I go way out to the left and to the right. Okay, listen, there's a lot of math in that equation. It might not be on your top 10 list of things that you're excited about, but it's important stuff that's part of our next topic. Now, we'll get to that graph next week, okay? Another graph, though, another equation is maybe a little more familiar, okay? Actually, it should be a little more familiar. We're not going to spend as much time with it, but it's a quadratic equation. A quadratic equation is an equation that has an x squared. And that should sound like some familiar information, but we're just going to focus on a little bit. When you have x squared, you get a special shape. You get, of course, a parabola. Okay, now parabolas are a big deal, okay, mainly because things in the real world often follow or have the shape of a parabola. One of the most common things is something that gets projected, something that gets thrown. If I throw this eraser up in the air, it's going to land on the ground. You can watch it land on the ground if you want, but I'd rather that you watch that it's going to follow this parabola, because anything that I throw is always going to follow the shape of a parabola. That's because of gravity. Now, but that's more for upstairs if you take physics and science. Downstairs, we want to talk a little bit about the specifications of a parabola. One of the biggest parts of a parabola, one of the most sort of special place on a parabola is the vertex. Now, again, as you hear this, you should be saying, yeah, I understand, I've heard this before, but I want to focus on it with you so that we can graph a parabola. When I say graph a parabola, I'm insinuating that we're going to do it without the help of a graphing tool. In other words, without Desmos. Because you could type this in Desmos and you could see the same thing. What we're going to try to do is figure this out, again, without a graphing tool. Okay, and that's going to kind of be the goal for this whole chapter. Now, if you haven't written something down, let me encourage you to probably write down that we're in Unit 9, if you would like to write that down. But we're going to start Unit 9 with quadratics. Okay, so we're going to start Unit 9 with quadratics. And this I would encourage you to write down because it's our topic 9.1. Now this will be a smaller stint. This is going to be a smaller thing here, not like weeks and weeks, just a couple days on parabolas. And what we want to do is we want to get kind of good again. If you were not good before, then we're trying to get good now for the first time. But when it comes to quadratics, they always have an x squared. And depending on what form they're in, for example, if they're in vertex form, we still have an x squared, but we see it written as x plus or minus h squared, and then plus or minus k. Now we call this vertex form because it makes it really easy to find the vertex. And you guys will find out before the period's over that that's h and k. H and k ultimately are the vertex. Let me show you the other form that you've also seen before. But again, we want to kind of get good at it again. And we call that standard form. Standard form ax squared plus bx plus c. I can say it, but I hope that you understand it as we go through this lesson, that both of these forms can represent the same parabola. But depending on which form you're given will kind of change the way you approach it. In other words, how you find the actual graph. And what we're going to do is we're going to use something I call the 5-point method to do that, to find the graph. Now, I kind of just coined the phrase 5-point method to try to help students think about these 5 points. Every parabola has the potential to have these 5 points. I say to have the potential. There are a few exceptions. But we have the vertex, we have the Y-intercept, the X-intercepts, and then a symmetry point. Now listen, the vertex, I'm telling, it's probably the most important point when it comes down to it. So I want to, hopefully we're not confused off the bat here. First of all, this h and k that you see, that comes from that vertex equation. But if I don't have h and k, then I'm going to use this formula. Okay, this is a formula. You're going to like this. So if you're not really sure what I'm talking about here, just wait. I just want you to realize this is a formula, opposite of b over 2a. And that will also give you the vertex. Okay, kids like this, again, because it's a formula. Now look, the rest of this stuff, x and y-intercepts, those are ideas that you've heard that since Alg 1. The cool thing is we can still find the x and y-intercepts if we have a quadratic. It's all about the number 0. Now the x-intercepts, there might be 2 of them. That's why you see 3 and 4 as your points. So the x-intercepts could be points 3 and 4. And then there's the symmetry point. A symmetry point, you'll find out, is more of a visual. It's found more using a visual inspection. Okay, the symmetry point is there's not a formula for it. There doesn't have to be, because again, it's just going to be like a visual thing. You're going to look at the graph and you're going to say, that's the symmetry point. Okay. This isn't a bad little lesson. I hope you feel pretty good today. There might be some things that you say, I've kind of seen that. Maybe there's some things that you're brushing up on. Remember, our goal is to graph this. Whether you kind of like it or not, we're going to graph this by finding these 5 points. Okay, it's negative x squared plus 6x minus 8. Okay, now I'll tell you, before we go actually find some of these points, a couple things that you should note. I know it's kind of obvious, but this is in standard form. Okay, it's in standard form. And secondly, it's got a negative leading coefficient. Now, that should catch your attention because that means the parabola is going to kind of look like the one up on my screen. It's going to open down. Okay, so just keep that in mind as we go through the next couple minutes. But most kids would jump in here and find the vertex. Okay, now the vertex for this standard form can use the formula opposite of b over 2a. It's pretty sharp. It's pretty simple because we just end up with the opposite of 6 over 2 times negative 1. Be careful, 2 times negative 1. Okay, so of course that comes out to be 3. Now it's an important little juncture you're at right now. You want to realize that that's only half of what you need. It was easy to find, but it's only half what you need because it's just the x value. Where's the y value? What's the y value? Well, the good news is the y value is the equation. And just like any math equation, if you plug in x, you will get the corresponding y value. And so we're doing a familiar math skill, again, just basically plugging in. Now, don't be bored by this because I'm telling you, this is where most of the mistakes are made, just like good old plugging in a number. I don't care if you use a calculator, but know your calculator. What I do care is that you realize that this is 3 squared, not negative 3 squared. Careful, it's 3 squared with a negative sign in front of it. Well, that's going to come out to be negative 9. Okay, I'm telling you, a common mistake is that kids will tell me that it's positive 9. But it's 3 squared with a negative sign in front of it. Okay, negative 9 plus 18 minus 8, you end up with 1. You end up with 1. That's pretty important because basically this parabola, everything is centered, everything is focused around the vertex. Let's keep on trucking here. We're going to find the y-intercept. The y-intercept is when x equals 0. Now, this might be the last time that you have to write this out, or maybe you don't have to write it out, because I hope that you're realizing that plugging in the number 0, it was made to be easy, right? When you plug in 0, you basically get 0. In this case, 0 minus 8. 0 minus 8. That's supposed to be easy to find. Okay, so we get 0, negative 8. Now the x-intercept, you also plug in 0, but you plug it in for y. And so it might make more sense to say that you're setting equal to 0. right? You're setting it equal to 0. Now, that should make you pause a little bit, okay, because this is a little different ball game. Do you know how to play this ball game? That's kind of my way of saying, do you know how to solve this equation? Okay, how do you play this ball game? Well, you could factor it. You could use the quadratic formula. Remember, that's kind of what we spent the last chapter focusing on. Now, if you're looking at this saying quadratic formula, okay, hey, you can use the quadratic formula. I like to look at this though and say, oh, it looks like I could factor it. It looks like I could factor it if maybe I just clean it up a little bit. Clean it up means I'm going to multiply everything by a negative because I don't like this negative x squared. I don't like the factor when the first number is negative. So you can just basically switch the sign. This is legal because I multiplied everything by -1. And now I hope you look at that and say, yeah, you could factor that with some basic factoring. Numbers that multiply to be 8, but add to be -6. So we can quickly arrive at -4 and -2. Of course, that's so we can get x equals +4 and x equals +2. Okay, keep in mind that that's what we really want, the x-intercepts. Oh, yeah, we just found the 2 x-intercepts. Okay, now I'm not going to give you guys a problem that's all wacko and has like really weird numbers. It's supposed to be something that you can go and graph, which actually that would be the next wise thing to do here. So we're going to graph this. Okay, it doesn't have to be on graph paper. It can just be a sketch, but let's try to get it about where it should be. I mean, there's the vertex. That means the y-intercept would be down here. Listen, you only have to label the points once. If you want to label them like I did in a list, then great. If you want to label them like I'm doing right here on the graph, fine. But if it really bugs you, you don't have to write the points twice. Now, I am writing them twice just to make sure we know what's going on, but do you see the parabola? It's not really like fully there, but remember, the parabola opens down. So a little bit of experience with this, you say, okay, if the parabola opens down, then what else could it do? You know, it obviously is going to pass through these points. It's going to get up to the vertex, looking good. Okay, this is obviously the way it's supposed to work because we're finding the 5 points on the parabola. Actually, we found 4 points. You're probably, I hope you're saying, what about the symmetry point? If it's all right, I'm going to squeeze that right here with a little abbreviation, but the symmetry point. Now listen, the symmetry point is to get you guys to think about a point that would be symmetrical with the y-intercept. And I will often denote it with a star. You should kind of feel like that point over there is like the missing piece to this parabola. So what is it? What is it? It's supposed to be found with like a visual inspection, just kind of like thinking about the numbers. What are you guys thinking? There should be 2 things that you're thinking. How about the y value? We're going to start with the y value. Okay, were you thinking it has to be the same? Okay, if it's going to be symmetrical, it has to be the same as the point that it came from. Now, there's one more thing you should be thinking, and I don't know if this helps or not. I don't want to overdo it, but there is a line that goes down the middle of the parabola. We call it the line of symmetry. But the point is that that line of symmetry is going to create a distance denoted by this yellow arrow and a distance denoted by this yellow arrow that, of course, are the same. So you should be thinking a little bit about this distance. Now, this distance is the number 3, which does have everything to do with the vertex, but that means that the distance has to be the same again, which, of course, will get us to the number 6. Now, you don't need to draw all that stuff if you don't want to. Just, you can look at it and you can just say 6, -8. That's your sim point. try one. Okay, be successful. Here's a quadratic. Remember, quadratic just means x squared. As soon as you see x squared, you're thinking parabola. I hope you're actually also thinking 5-point method. Are you willing to try to find as many of these 5 points? That you're starting with the vertex. Okay, so we got 2x squared, 8x, and 7. See if you can get this right, especially the vertex. Everything is based on the vertex. As I said briefly, it is okay to use a calculator. Just make sure you know your calculator. Maybe better yet, you try to do as much as you can without a calculator. Try to plug in -2. I'm telling you, that is usually the place where mistakes are made, and it kind of stinks because it's the vertex. You don't want to mess that up. You plug in -2. You do the good old order of operations. You should be squaring first. Double check your answer. I'm not going to say it out loud, so you can double check it when you're ready. If you do want to have these 2 numbers as you go on your way. Please make easy work of the Y-intercept. The Y-intercept is, honestly, it's the C value. It's set in. However, the X-intercept, I don't know if you're going to make easy work of that. Okay, I actually gave you a problem that requires the quadratic formula. If you weren't sure, yes, you can't factor that. So, for better or worse, you got to use the quadratic formula. Listen, the quadratic formula is a big deal around here. I know for some of you on the test you just got back, there were some issues with just trying to get that thing cleaned up correctly. You can still learn it. You can still try to get it right. It's the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. B squared minus 4ac. A lot of stuff in there. B squared minus 4ac. If you want to double check, it just becomes this single digit. I'm going to skip writing that all down on the board, but you get to this nice little step. Now listen, if you're kind of waiting for me, that's fine. That's why we're in class, but can you simplify this? Again, I know on the test that for some of you I put some red marks down to try to help you simplify better and better. Square root of 8, you got to see that as 4 times 2. And of course, 4 is a perfect number. So 4 is able to break out. And when it breaks out, it turns into the number 2. Of course, the white 2 stays behind when you get 2 root 2. I know you might say, why do I have to simplify? I mean, it's just kind of part of math that we try to give the answer in its simplest form. Here's kind of the how the story goes. You should divide by 4 because you can divide by 4. You should because you can. So yeah, negative 8 divides by 4, and we get negative 2. Now, the 2 that's in front, it kind of like reduces with the number 4. Okay, yeah, it reduces to be a half. So I'm going to argue that that's our goal, to get to negative 2 plus or minus 1/2 root 2. It is a little simpler because the numbers are smaller. Are you willing to try to graph what we have up here? Maybe you're not sure about how to graph the goofy plus or minus 1/2 root 2, but are you willing to try to graph something? That's our goal, is to try to graph this equation. If you're just graphing the vertex and the Y-intercept, okay, I mean, that's a start. Kind of looking for my advice, I'm going to say honestly that at this point, meaning a vertex and a Y-intercept, you can draw the parabola. I guess you have to be a little bit confident that a parabola of this variety is going to have to, well, it's going to have the vertex at the bottom. I mean, it's got to pass through that Y-intercept. So again, what else can it do? It has to look like this. Now I know we only graphed 2 points, but the reason I did that was now I can go back and I can understand a little bit more about this x-intercept. You see, that x-intercept has to be the minus of my conjugate. So it's negative 2 minus 1/2 root 2. I know it's a little bit weird, but a minus sign has to be the one on the left. In a similar fashion, the one on the right has to be the plus 1/2 root 2, because a plus sign would have to give me the one that's bigger. Now, if it makes you feel better, you can turn those into decimals. I don't have those decimals available, but yeah, on a calculator, you can turn those into decimals and you can see that they're both going to be negative. All right, so that's about as fancy as it could get. We still need a symmetry point. Just give you a moment to think about it because it's supposed to be a visual. It's supposed to be a visual inspection. I hope you're getting a little bit of an always for the symmetry point. Always at the same y value. Now, always equally spaced. Negative 2 is kind of our magic number. Negative 2 is the distance of this equal space. Negative 2 was that vertex from the beginning. Okay, so a pair of negative 2s are going to get you to negative 4. one other problem I want to do. We'll be able to roll through it a little faster, as maybe you're wondering about vertex form. Did you remember that vertex equation? The one with H and K? What if I give you an equation in vertex form? Well, I think you're going to say, I hope you're going to say, it's actually a little easier. So let's see if we can get to that point. I know we only have a few minutes, but it might be all we need. Here I have the quantity x minus 5 squared and then minus 10. Now look, as soon as you see that, you should say vertex form and leave it in vertex form. Here's why. It gives you the vertex. Okay, now remember, if I subtract a number on the inside of the parentheses, that means you shift to the right. It's just 5. Because if I shift to the right, I have to be at an x value of 5. If you subtract on the outside, that means you shift up and down. So in 10 seconds, I have my vertex, 5, negative 10, because it's in vertex form. Now, be careful. The Y-intercept, it's still all about the number 0, but please don't haphazardly tell me that it's just negative 10. That would be a little sloppy. Instead, you want to plug in 0, and you should see a little bit of arithmetic. So, of course, negative 5 squared is 25, minus 10 is 15. So it takes a little bit of arithmetic to get the Y-intercept. How about the X-intercept? Again, I think you're going to say it's actually a little easier when you're in vertex form. Now, that's another equation to solve. Okay, again, how do you play that game? Don't use the quadratic formula. Do use a little algebra. Sprinkle a little algebra on this side, and you add 10. Sprinkle a little algebra on both sides, and you take the square root. So what's really happening here is I'm solving an equation very carefully, using the order of operations the right way. So I add 10, I take the square root. We're almost home free here. Plus or minus root 10. That'll be plus or minus root 10, right? So that I can add 10, check that, 5. So I can add 5. Now, for most of us, it's just how do you write this? And you simply write it as 5 plus or minus root 10. Now 5 plus or minus root 10 is, or are, the x-intercepts. And it's another little conjugate, or kind of like a decimal. I'm going to stop there. I don't want to hurry up and draw a graph, but we would need to draw the graph and find the symmetry point. But that would work out the same as it did for the other one. Get off to a good start. I hope that you already feel like you have, but get off to a good start. There's 3 of these parabolas on the homework helper. Okay. Check them out. Be careful as you don't look at the answer key too quickly. Don't look at the answer key too quickly. Try to leave that covered up at the bottom of your screen.